All right, you guys. So today we are doing another video on horizontal asymptotes, but this time we're looking at functions that kind of look like this. They have something to the power of x. So maybe it's 3 to the power of x, maybe it's 5 to the power of x, maybe it's e to the power of x, because I know you guys like this applies for all of it. So how did we find the horizontal asymptotes last time? Well, we found the term, but we only did that to see what eventually is going to look like, right? Made it easier to find out eventually what will our function look like. So I am just going to figure out eventually what does this look like, and I don't have to use any leading terms or anything like that. I can just kind of plug it in. So here we go. So let's say, right, I don't really care what it looks like here. If I want to know what the horizontal asymptote is, I need to know what it looks like eventually on the right side and eventually on the left side, okay? So what would it look like eventually on the right side? Well, eventually, that means I'm like plugging in really big numbers for x, right? Like eventually might be when like x is like 1 trillion, right? I want to see what y will be. So I'm going to plug in really big numbers for x, and I'm also going to plug in really big negative numbers for x to see what it'll eventually look like on the left side. So maybe I'll plug in negative a trillion or something like that. I don't know. Okay, but let's start with the right side. Let's see what happens if we plug in really big numbers for x. Well, I'm going to get -2 to like some huge number. Maybe it's a trillion, maybe it's like 9 Googleplex, I don't know. But I'm going -2 to a really big number plus 1. Okay, well, this is 2, or -2 to a big number plus 1. What's 2? It's like a real, like if I took 2, and let's say I squared it, okay, that'd be 4. 2 cubed is 8. 2 to the 4th is what? 16. So it looks like if I raise it to a really big power, it's just going to be a super big number, right? So if I take 2 and raise it to like a huge power, well, that's just going to be like another really big number, right? So now what I'm doing is I'm doing a really big negative number plus 1. Okay, well if I have like negative a trillion and I add like 1, it'd still be like negative a trillion, right? It's like saying, let's see, you you owe $1 trillion, and your friend's like, I feel so bad for you. Here's $1 so you can help pay it back. And you're like, thanks. I still owe basically $1 trillion, right? Okay, so a negative number plus 1 is like still like a negative big number. So what does that mean? That means eventually on the right side, I don't know what this function looks like. Might look crazy, but eventually on the right side, it's just going to get more and more. Oh, come on, stylus. There we go. It's going to look more and more negative. So it's just going to keep going down and down and down and down and down and down forever and ever and ever and ever and ever. Okay, it's just going to keep going down. That's what it means. All right. So I'm just going to draw that over here so I kind of remember. Like it just keeps going down, right? Okay, so what happens if I plug in a negative big number into this? Well, let's try. So I have -2 to a negative big number. And remember, this is actually -2 because there's like no there, it's not that. There's no parentheses. Okay, so -2 to a negative big number plus 1. Well, anything to a negative number, like a power of it, is just 1 over that thing to the same power, right? Like 2 to the -3 is equal to 1 over 2 cubed. So 2 to a negative big number is the same as 1 over 2 to a really big number. But what is this? Well, 2 to a big number is just another big number. And if I had 1 pizza and shared it with 1 trillion gazillion people, I'd basically have nothing. So 1 divided by a big number is like basically 0. So my function eventually on the left side is basically going to be 0 plus 1, which means it's basically going to be 1. that means eventually my function, whoa, does all this weird stuff, eventually it's going to look like the function 1. Okay, so what does this mean? Well, that means that my horizontal asymptote is y equals -1, because that's that line right there, right? So I know on this side it doesn't like that, it doesn't really apply, like asymptote. It's not affected by the asymptote, but over here it is. And so I am going to write y is equal to -1 as an asymptote. Okay, so that was one of the problems. We're going to do another one, and then I'll show you an easy way for when you're on the test and you're freaking out, because trust me, I have been there, I understand. So let's go ahead and do this one. So we're going to do the same thing we did before. I'm going to see what happens when I plug in really big numbers for x, and I'm also going to see what happens when I plug in really big negative numbers, or like -1 trillion or something. Okay, so but this time I have this function, y is equal to 3 to the -x plus 1. So if I plug in a really, really big number, that'd be 3 to a negative really big number, right, because that's a -x there, plus 1, which would be like, well, remember, 3 to the negative power is the same as 1 over 3 to the positive version of that power. Okay, and 3 to a big number is just, right, because like 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, so 3 to the like a million is like just a really big number, you guys. Okay, plus 1. And let's see, this big number, well, 1 divided by a big number is like basically 0. So I can just write this as like, this is basically 1. So I don't know what happens to my function in the middle. Uh-oh. Ay, ¿por qué no quieres funcionar, por favor? Okay, so it's like something happens in the end, and then eventually, it's going to look kind of like 1. It's going to like kind of reach 1. I know some of you are saying now, oh, that means the horizontal asymptote is 1. You're correct. Since it'll eventually look like 1 on the right, or like reach like about 1, that would be our horizontal asymptote. And notice because it's about 1, it actually like won't really touch 1 on the very, very, very far right, but it's like about 1. So that's why it's the asymptote. And then what happens on the left side? Well, let's plug in a really, really, really big negative number. So I get 3 to the negative big number plus 1. Well, negative is a positive. 3 to a big number is just another big number. A big number plus 1 is again a big number. So on the left side, I don't know what happens in the middle, but eventually on the left side, it just keeps going up and up and up and up and up for like ever. All right? So now I want us to notice a pattern for when you're on the test, right? Because some of you are like, okay, I'm kind of getting this like big number thing. You just like plug it in. I'm looking at the end behavior. We call it the end behavior of the graph on the right or on the left. And you're like, okay, cool. So like I have to look at both sides. If one of the sides like just becomes something like that, then that's my horizontal asymptote. Okay, I kind of get it. Cool. But if you want to go faster, I want us to point something out. Notice how, like, I don't know if it was a big number or like a negative big number I plugged in, but eventually on one of the sides, this became like kind of like 0, right? Like here, if I plugged in a big number, this became basically 0. And so my horizontal asymptote was just this number right here. And let's look back at the other one too, right? This, eventually on one of the sides, when I plugged in stuff, was like basically 0. And so my horizontal asymptote, wait, did I write y equals -1? Oh my gosh, I'm so sorry, you guys. I'm like such a mess. +1. Oh, I feel so bad, but I'm not going to re-record this whole 10-minute video. Lol, sorry. Okay, anyways, so that's +1, and our horizontal asymptote was 1, right? So if I'm looking at, ooh, what's this? Oh, that's not it. I want to see what that's weird. Okay. Anyway, so if I'm looking at this term right there, Like if I have 2 to the something or e to the something, my horizontal asymptote will always be whatever's right here. So that's plus, or y equals 1 in this case, happened to also be y equals 1 in this case. But let's say instead this had said like plus 5, then my horizontal asymptote would be 5. Y equals 5. Let's say it said minus 3 instead. My horizontal asymptote would have been negative 3. So for power functions like this, my horizontal asymptote will always be y's equal to whatever is right there. And I hope that helps. I'm really sorry about, like, I know I totally confused some of you with this one right here and that like -1 +1. Lol, whoops. So sorry. I'll probably put a comment in the beginning. We'll see. I'm pretty lazy. All right. Hope this helped a little bit. We're going to go over one more example in the next video.